Now let's look at Newton's laws of motion. There was a guy, he was called Isaac Newton, and he studied materials and he studied motion, and he made a number of observations, and he reported what he saw in three statements we call Newton's laws of motion. The first one was that every body continues in its state of rest or uniform motion. This is uniform rectilinear motion unless compelled to behave otherwise by an external impressed force. So we are saying that everybody shall always persevere in states of rectilinear motion, uniform rectilinear motion. There are some terms here: uniform, rectilinear, then impressed. Those terms there. Rectilinear motion, that is motion in a straight line, and then impressed force, that shall be a resultant force in a particular direction. If there is no resultant force, the body shall always remain the way it is. If it is moving with a constant velocity, it shall continue doing so unless a force, which is a resultant force in a particular direction, is applied on it. If the force is a retarding force, there shall be some bit of stopping or reducing the speed. If the force is an accelerating force, the body shall have its velocity increased. And if the force is applied for a body which is moving in uniform rectilinear motion, it can, once you apply the force, you can have the speed changing or the direction, such that a body which was moving in a straight line changes direction and can no longer move in a straight line. And when the body is at rest, of course, you need some force. You can have if it is supposed to start moving, you must have a resultant force. But if you have, I can illustrate here, if you have this body here, and you have a force of maybe 4 Newton is there, and you have another now of 4 Newton is there, that means that in that case there is no resultant force. So that body shall still remain there. It shall remain stationary. It shall continue. If it was stationary, it shall remain so, because there is no impressed force, there is no resultant force. But if you have something like this, you have 6 Newtons, and then you have maybe this one, maybe 3 Newtons, and this one is a smooth surface, so there is no friction. You realize that there is a resultant force of 3 Newtons, which is 6 minus 3 towards the right. And so there will be a resultant force there, and that body can move. And it can be set into motion because there is a resultant force there. Now there is also Newton's second law, which says that the rate of change of momentum of a body is directly proportional to the applied force, and it takes place in the direction of the force applied. And we have this supposition. Suppose a body of mass m kilogram moving at a velocity v meter per second is acted upon by a force F Newtons, then this is correct. This one is the statement of Newton's second law, that the rate of change of momentum is proportional to the force applied. And then we have this, that is the mathematics there. Then they are saying that it must be in the direction of the force. This is what we need to know. Momentum is equal to mass times velocity. So if we talk about the rate of change of momentum, which is dp dt, then we have d dt of, instead of p, I have mv. But now what we need to know is that m is a constant, so it can move out, and instead of having m d dt, of mv, we have m times dv dt. But now this dv dt is the rate. You people, when they talk about dy dx, they are meaning the rate of change of y with respect to x. By how much does y change whenever there is a change, a particular change in what? Change in x. So when I write dv dt, I am talking about the rate of change of velocity with the time. And the rate of change of velocity with the time is the acceleration. So this thing here is a. We can replace it with a. It is what we are doing here. That f varies as m times dv dt. Since m is constant, it can be multiplied after the derivative. You know that from paper 1. But is acceleration, the rate of change of velocity with the time. And the f, it means that when you are removing the variation sign, you say that f is equal to k times ma. And the scientists made some experiments and they realized that a force of 1 Newton can give a 1 kilogram mass an acceleration of 1 meter per second. That experiment gave a result when they used a force of 1 Newton and it was applied on a 1 kilogram mass. It got an acceleration of 1 meter per second. And if you substitute those values, 1 here, and 1 there, then you are going to have that k is equal to 1. From the fact that a 1 kilogram force, a 1 Newton force will give a 1 kilogram mass an acceleration of 1 meter per second. And that one means that F is equal to ma. We are going to use this expression a lot in Newtonian kinematics. It's going to be used a lot here. So F is equal to ma. What I want you to note is the fact that the F which is involved here is a resultant force. That force is the resultant. So the resultant force is equal to m times acceleration, mass times acceleration. The third one is saying that action and reaction are equal but opposite. So we are saying that whenever there is an action, there is an equal but opposite reaction. Now we are saying that consider a body of weight W resting on a horizontal surface. We have this body. When that body is resting there, we shall have that the weight of the body is acting vertically downwards. And because of the weight of the body applied on the surface, there will be a reaction which we call the normal reaction, because it is normal to the surface in contact with the body. So there will be a reaction. And now what this law 3 is trying to tell us that R is equal to W, because once the weight is acting downwards, we are having an upward force in the opposite direction. And understand that force will be equal, because now what is the action? The weight. What's the reaction? It is that R acting upwards. That's what we have there. It is just what they wrote here, down here, that the body will exert a force equal to its weight on the surface, and the surface will in turn exert an equal but opposite force on the body R, known as the normal reaction. And now from that third law, we are saying that R is equal to W, that this reaction is equal to W, provided that R is equal to W. Of course, when the body is just resting there, it is not moving either upwards or downwards. Sometime later we shall look at motion in a lift, and we shall see that when the surface is moving, for example, upwards, that R may try to vary, may not be the same as the W. We have this example. They are saying that a body moves horizontally at a constant speed of 5 meters per second, subject to the forces shown. Find P and S. Now, we need to take a note of these words. The body is moving horizontally with a constant speed. We have those terms: constant speed, moving horizontally, and this is the constant speed. Subject to the forces, they are saying find P and S. Now this is what you need to take a note of. This is what you need to know. If a body is moving with a constant speed, it means that the forces in any two opposite directions is equal. The sum of the forces in any two opposite directions is equal. So that means that if I have this body and it is in motion, and I have that this force is R, and I have another force maybe Q this side, if this body is moving with a constant speed, then Q will be equal to R, because the speed is not changing. We have a constant velocity, not changing, so there is no resultant force. So that means that the two forces are the same. So from here, it means that from what we have here, the implication is that since there is the horizontal motion is constant, then P is equal to 200 Newton. Is that the P here is equivalent to this one here. Why? The body is moving with a constant speed. There is no resultant. Then the body is moving horizontally. That means that there is no vertical motion. So considering that there is no vertical motion, I shall have that the upward forces, the forces acting upwards, shall be equivalent to the forces acting downwards. So we have this S acting upwards and that S acting upwards, given by, as you can see, the way the arrows are indicating. So we have that S plus S should give us 2000. This is 2S is equal to 2000, implying that S is equal to 1000 Newtons. That is the value of S. Let's look at the inclined plane. What happens on an inclined plane? We are saying that a particle on an inclined plane is acted upon by its weight vertically downwards, and the normal reaction are perpendicular to the plane. The weight can be resolved along and perpendicular to the plane in two components, W sin alpha and W cos alpha respectively. If no external force acts on the particle, it will slide downwards under the influence of W sin alpha. And so we are saying that the resultant force there, W sin alpha, and it is equal to M times A. We'll look at this. I have this one. This one is alpha. This body here, when the body is on the incline, there will be a weight. The weight of any body will always act vertically downwards, and it is given by mg. Now we are saying that this mg can be resolved into perpendicular directions, and the one direction, this one is along, this one is perpendicular to the plane, normal to the plane, and then this direction here, which is this side here, which is along the plane. So if this one is alpha, by looking at the geometry, you are going to realize that this angle here is also alpha. That angle, which is the same as this angle here, it is also alpha, by considering the fact that you can use geometry to establish that. And if that is the case, we have that this side is remember I told you that whatever you are resolving into perpendicular directions should be the hypotenuse. So this one is the hypotenuse for this particular triangle, this one here. So along this hypotenuse you have mg, and you are resolving it along this one and that one. If this one is A, this one is B, you have that A is equal to mg cosine of alpha, and then B is equal to mg sine alpha. So the component along the incline acting downwards, it is mg sine alpha or w sine alpha. If I say that instead of saying mg, I write w to denote the weight of the body, and then I have the component w cos alpha perpendicular to the plane, and that component is the one which shall now counterbalance the normal reaction, the force exerted on the object by the plane, by the surface. That's what we have. That is happening if the body is you have no tractive pull acting in this direction, that is not being pulled up there. There is no force acting in that direction. Then in that case, the body shall be sloping downwards because of the impact of the w sine alpha. The component along the incline shall make that body to slide downwards if there is no force pushing it upwards. So we have the R there, then we have mg sine alpha along with that, then we have mg cos alpha perpendicular. That's what we have. Now we are saying that if the plane is rough, then friction will come into place. So if you have a rough plane, like the plane is rough and there is no force which you are not applying it, you are not applying a force there. So this F here is not a force which is pushing the body upwards, but it is a force which is stopping the body from sliding downwards. That is the frictional force. So as the body is tending to move downwards because of the effect of w sine alpha, the friction will be resisting that type of motion by acting in the opposite direction. So when the frictional force comes into play, we have still we have the reaction, we have the w cos alpha. The w sine alpha is now being opposed by that friction, and that is the only difference. But for this case, instead of having that w sine alpha is equal to ma, we now have a resultant force which can be got by w sine alpha minus f, because the body, if the body moves downwards, really it means that the frictional force is smaller than the w sine alpha, and in that case we shall be having that w sine alpha minus f is equal to ma. This one would be the resultant force along the inclined plane. So the resultant along the incline is w sine alpha minus f, such that it is now equal to ma. That is in accordance with Newton's second law, that the resultant force shall always be equal to the product of the mass and the acceleration produced on the body. So we are saying that now w sine alpha minus f is equal to ma, where f is the frictional force. What can we say about slope of an incline? Slope, because you may find that some inclined planes are steeper than others. Others are steep, others are gently sloping, others are So there is that concept, there is that dimension, there is that property, slope of an incline. And we are saying that actually it is the degree of steepness of the incline. When the slope is big, you have the incline very steep. When the slope is small, you have that the steepness is not big. So we are saying that the slope of an inclined plane is 1 over x. That is the slope. Remember, so slope is vertical rise divided by horizontal displacement. So the slope will be this vertical rise divided by the horizontal displacement. So if this is 1 unit divided by x, which is that distance, and I say that this can be expressed as 1 in x. you shall be seeing question is what they tell you that they see this one will begin an ascent of a slope of 1 in this one. So when they say 1, if the slope is 1 in 1,000, it means that the slope is 1 over 1,000, and in most cases that one is the same as the tangent of alpha. Yeah, because if this is alpha, this is opposite, this one is adjacent, and tangent of alpha is equal to opposite over adjacent. So the opposite, which is 1, divided by the adjacent, which is x. So we can able to say that tangent of alpha is equal to 1 divided by x. That is tangent. However, we are saying that if it happens that alpha is very small, and particularly in radians, then you cannot make a distinction between tan alpha and sin alpha. So we shall able to say that sin alpha is also approximately equal to 1 over x. It is true tan alpha will be equal to 1 over x. But when alpha is very small, there could be no difference between tan alpha and sin alpha, because tan alpha is 1 over x. But if this x is very big, you may find that if you try to get the hypotenuse, it will be not very different from this other side here. It will be almost the same, such that getting the sign which is opposite over hypotenuse, you get almost the same thing as getting opposite over adjacent. Just check for yourself if x is, you are going to check this one, if x is 1,000, you try to get the value of this hypotenuse, and then get tangent of alpha, which will be 1 over 1,000, and then get the tangent. Also try to get the sine of alpha, which is equal to 1 over h, and try to get me the answer to 3 decimal places, and try to see what you are going to get. There will be not too much difference there for a very small angle alpha. That is what you need to know about the slope of an incline. 1 in x, that rendering of slope, you should take note of it. 1 in x, what does it mean? It means that the tangent of the angle in question is 1 over x. Take note of that. Examples: a body of mass 100 kilograms is acted upon by a force of 7 newtons. Find the acceleration of the mass, how long it will take to acquire a velocity of 15 kilometers per hour. This can be the analysis of the question. M is equal to 100 kilogram. Force, which we can call F, is 7 newtons. We are looking for acceleration, but remember Newton's second law gave us this formula that F is equal to ma. That will imply that A is equal to F over m, which is equal to 7 over 100. You can write this one as 0.7 meters per second squared. That is the acceleration. So this is Roman 1. For the second one, how long it will take to acquire velocity? How long is a requirement of time? So we are looking for time, and the final velocity acquired is 15 kilometers per hour, which we can have, you remember this, 15 kilometers per hour is the same as 15 kilometers over 1 hour. So you can have 15 times 1,000 meters over 3600 seconds. That's when I want to get it is as in meters per second. So I have 15 times 10 over 36. I shall be using this conversion that whenever I shall be in need of converting from kilometer per hour to meter per second, I shall multiply by 10 over 36. I have just showed you how it comes about. Multiply by 1000 divided by 3600. So when you cancel the two zeros here, you remain with 10 over 36. But at the end of it, this one is going to get us 25 divided by 6. So this one is the same as 25 over 6 meters per second. Now we are looking for, we have got acceleration as 0.07 meters per second squared, and we are looking for, actually u shall take a 0. U is equal to 0 because they didn't say that this body was moving at any velocity, so it was at rest. We now use the fact that v is equal to u plus at, and v, which is 25 divided by 6, is equal to u, which is 0, plus a, that one is 7 over 100 times t, the t which we are looking for. And I can say that now t is equal to 25 times 100 divided by 6 times 7, and we have that t is equal to 59.5 seconds. That's the value of t. Question finished. Let's do this. A locomotive of mass 200 tons has attractive pull of 35,000 newtons and experiences a resistance of 88 newtons per ton. Find the acceleration of the locomotive. This diagram is not part of your question, it is part of the solution. So the question ends here, and you as a candidate, you are supposed to apply this. If you are to use this diagram, you can use it to help you answer the question. So I'm looking at a scenario where this locomotive is moving to the right, towards the right, and the attractive pull is that pull which is provided by the driver putting his foot on the acceleration pedal. That is the force due to from the engine now. So it is a forward force of 35,000 newtons, and we have a resistance of which they are saying that it is 88 newtons for every ton. Now that this locomotive has 200 tons, it must be having that the resistance R is equal to 88 newtons per ton, and this one means that this one is 88 times 200, and this is that's what you get there. That one is in terms of that is resistance. Now if this body is supposed to accelerate, you have this force. Of course this force is greater than the resistance, so there shall be a resultant force towards the right. So we have that resultant, this is now resultant force, which we call F, is equal to 3500 minus 17600 This is going to get us 174.00 newtons. That is F, the resultant force. But remember, from Newton's second law, that F is equal to ma. The mass is something which we know. Actually, mass is equal to 200 tons, which is equal to 200. Each ton contains 1,000 kilograms. So the 200 tons will be containing 200 times 1,000 to convert it to kilogram. This is 2 times 10 power 5 kilogram. And so we can say that F, which is 176.0, actually it is 174.00. This is F is equal to mass 2 times 10 power 5, then times A. So I'm substituting the values I know. I know this one, I know this one, I'm looking for this. So the known values I'm substituting, and now I'm having that A is 174.00 divided by 2 times 10 power 5, giving us a value of A which is equal to 0.087 meters per second squared. That one happens to be the acceleration of that locomotive. Example next, a ship of mass 10,000 megagrams slows with its engine stopped from 12 km per hour to 10 km per hour in a distance of 90. Assuming the resistance to be uniform, calculate its value in newtons. We have a uniform resistance. So it is because of the resistance that we have had a vehicle which was traveling at 12 to change to 10. But in changing from 12, naturally it is a ship, changing from 12 to 10, the distance covered was 90. We can analyze this question like this. We have U. Actually, we can start from the mass. Mass M is equal to, this is 10,000 megagrams. This is how we render that, capital MG. And now the word mega means a million. So we have a million grams in 1 megagram. But now these are 10,000 megagrams. So we have this one as 10,000 times a million grams. Those are grams. But we must also, because we need to have it in kilograms, we have to divide by 1,000, which is the same as multiplying by 10 power negative 3, because 10 power negative 3 is the same as 1 over 10 power 3, which is equal to 1 over 1,000. So we are dividing by 1,000 by doing this. Multiply by a million to get to grams, divide by 1,000 to get to kilograms. These are kilograms. And everything is 10 power 7 kilograms, because this one and that one will get us 10 power 3. Then these are 1, 2, 3, 4. 10 power 4, 10 power 3. You have 10 power 7. That is the mass, the one which we have there. Initial velocity, they say it is 12 kilometers per hour. I told you I shall be multiplying by 10 over 36. So I have this one as I guess I have 10 divided by, it is 10 over 3. This one is in meters per second. The final velocity is 10 kilometers per hour, which is 10 times 10 over 36, getting us 25 divided by, that is 25 over 9. still in meters per second. In this question, we're going to need the value of the acceleration. We can get it from the fact that v squared is equal to u squared plus 2as. V is 25 over 9. We have that squared is equal to u, which is 10 over 3. We still have that squared plus 2 times the value of a which we are looking for times 90, because the speed changed from 12 to 10 in 90 through a distance of when the distance and the distance covered was 90. By changing from 12 to 10, there was a distance of 90 meters covered. So the s is 90. Initial speed, initial velocity, this one, final velocity, we substitute like that. That's what we have. 25 squared is the same as 625 over 9, which is 81, is equal to 100 divided by 9 plus this one is 180 times a. So we have that a itself is negative 1 over 180 into 625 divided by 81 minus this one is minus 100, can say 100 divided by 9. Also this one is not minus, but this thing here is going to get us a minus, such that the overall thing is negative 0.0189 meters per second squared. That is the value of a, and is becoming negative because actually what we have here is a deceleration. The initial one is the final velocity is smaller than the initial velocity. So we have that this difference is going to get us. That's what we have as the value of a. Now this diagram here, it was not part of the it was not part of the question. I am using it as it is part of the solution. So if this ship is moving towards the right in this direction, it was moving like that, it was moving there, and because the engine was switched off, it went on reducing from 12 to 10. So that means that if the engine is switched off, it means that this f is now what is 0. So we have f as being 0. F is 0. That is the tractive pull of the ship. So now the resultant force is going to be the 0 minus r. It is going to be the one which is equal to m what? It is equal to ma. So 0 tractive pull, which is stopped, minus r will be equal to ma. And so we have that negative r is equal to ma. And now what we are looking for here is the value of r. So negative r is equal to the mass. We got it as 10 power 7. We got acceleration as negative 0.0189. And so we have that r is equal to 189.00 Newton. That's the value of the resistance. It is the resistance which is offered to this form of motion. Check on that. If there is any problem somewhere you are not getting properly, you have the group where you can always ask on the Telegram channel. Of mass 30 grams is fired with a velocity of 150 meters per second into a fixed block of wood, and it penetrates 8 centimeters before coming to rest. Find a velocity with which it will emerge from a thick board of 4 centimeters thick, assuming the resistance to be the same in both cases. this is what we are going to have. Can assume that this one can be a block of wood, and the bullet enters from there, and maybe we can have that maybe 8 centimeter ends here, so that this one is 80 centimeters. And now at the end of it all, when the bullet is here, that is when it is at rest. And so at this starting point, the bullet enters there with a velocity of 150 meters per second, and at the end of the 8 centimeters, it is at 0 meters per second. Or the saying that it penetrates 8 centimeters before coming to rest. And that's the situation we have. So we have that U is 150 meters per second. The final velocity is 0. The distance covered is 0.08 meters, converting this one to meters by dividing by 100. So we can able get the value of the acceleration in that case. So you have that V squared is equal to U squared plus 2AS, implying that 0 is equal to 150 squared plus 2 times A, which is the one we don't know, times S, which is 0.08 meters. Now here we shall have that A is equal to negative of 150 squared, and this one divided by 2 times 0.08, and we shall have this one. It is you square, it is negative of 150 squared. So don't think that we are going to have the negative cancelling. There is a difference between this negative 150 squared and then you see those two, they are not the same. This one is positive and this one is negative. So the value of acceleration is negative. You press the calculator, that is 140,625 meters per second squared. That one indicates that is a retardation. So there was a deceleration of this much. The wood has been able to stop a bullet which was moving at 150 meters per second to 0 in just a distance of 80 centimeters. That was a very big deceleration. It was a very big acceleration in the negative. So it was a big resistance which was offered. And now, assuming the same resistance, if this thing is made to have a thickness of 4 centimeter here, it means that remember this thing has exited with this acceleration at 4. The thing passed there, the bullet passed there. So that means that if the wood is made to have a thickness of only 4 centimeters, the bullet will pass there with a certain speed which we can call what? Which we can call V. So we shall have that the acceleration is still this one, but the final velocity is now becoming the one which we want there, and the initial velocity is still 150. So if the wood has 4, if you have the board, actually it is a block of wood. So if the thick board has 4 centimeters, we shall have that S is equal to 0.04. However, the resistance offered is the same, so shall be having the same deceleration, the same A, which is 140,625 meters per second squared. And we shall say that V squared is equal to U squared plus 2AS. V squared is equal to 150 squared plus this is 2. The value of A is 140,625 squared. It is not squared, man. Times S, which is 0.04. This time that's what we have, 0.04. It was in meters. So when you press the calculator, 150 squared, this one time plus 2 times this one as negative, you are going to get a value of V, which is equal to, actually this is 11250, such that V itself is 106.07 meters per second. That's the velocity with which this thing is going to emerge from this. So it was from here, it covers 8 centimeters to become 0. If it is at around if the thing is just 4, it will emerge at this point with a velocity of 106.1 meter per second. That's what we have. This one is saying that a bullet of mass 30 grams. We have a mass of 30 grams. This is the same as 0.03, and it is 0.03 kilograms. Is fired into a fixed block with a velocity. So we have a velocity of 294 meters per second, and it is brought to rest in the time which is 1/150 seconds. They want to find the resistance offered. So what we need to know is that the resistance will be equal to, have this one as the bullet, that is the bullet, forward, we have forward, and then resistance, and you realize that F is equal to 0 because the bullet is not being driven, it's not being dragged, it is just projected and is going. There is no force, which is no accelerator pedal within the bullet. It is just so there is no forward force to it, say for the momentum it has acquired on projection, and so F is 0. If you are to get the resultant for a bullet moving in that direction, and but stopping somehow, coming to rest, shall have that F 0 minus R is equal to MA, implying that negative R is equal to MA. That is the equation we shall use to get the value of this R. And now it was moving at this one, and the final velocity is 0, and that is the time. So we have U, we have T and V. We can get the value of A. V is equal to U plus AT. Final velocity is 0. U is 294, and plus A, the I'm looking for, the time is 150. So we have that when this one goes to the left, it becomes negative. I think we prefer to, let's take that one, so that we have that A is equal to negative of 294 times 150 to get us a value of A, which is 441.00 meters per second, but in the negative, meters per second squared in the negative. And now we can put it here. We have that negative R is equal to, the mass was given as 0.03, the acceleration is 441.00. So we have that R itself, the resistance force, is now equal to 1323 newtons. That is what we are going to get if you press the calculator. So you use the dynamics of a particle to get the acceleration, and is giving us the deceleration. So which force was responsible for that deceleration? Which is the resultant, which was, for this case, it was only the resistance force, because there was no force, there was no forward force. So the only retarding force we had here, which was the resultant force, was a resistance force, which is R, and it is that resistance force which is equal to MA. So we have that resistance force is MA, but our is negative because it was a deceleration, and that gave us our answer there. This one is saying that a mass of 10 kg rests on a horizontal plane which is made to ascend Roman 1 with a constant velocity of 5 meters per second. Roman 2 with a constant acceleration of 5 meters per second squared. Find in each case the reaction. They want us to obtain the reaction in each case. If this one is the surface, and that is the body resting on a horizontal plane, there will be a reaction R because of a weight downwards, which is M, because of a weight mg. Now there we are. When the body is moving, this is Roman 1, if the body is moving upwards with a constant velocity, it means that the forces are counterbalancing one another, that there is no resultant force. That means that the upward force is equal to the downward force. In other words, acceleration is equal to 0. And now this body is moving, we are having an ascent, meaning that we are supposed to have R minus mg, that will constitute the resultant force. But now we are saying that it is equal to ma, but this time A is equal to 0. Why? Because the body is moving with a constant velocity, and if A is 0, it means that R is equal to mg. So the reaction R is equal to M, which is equal to 10 times 9.8 for the reaction, the gravitational acceleration. So we shall have a value of R equal to 98 newtons. Then Roman 2, I shall use that same diagram. If this body is moving upwards with an acceleration of 5 meters per second, we now have that A is not 0, but it is 5 meters per second squared. And by having that R minus mg equal to ma, we shall have that R is equal to m into A plus g, by making R the subject of the formula. So we have that R is equal to m, which is equal to 10, 9.8. How shall we have the acceleration is 5 plus 9.8. This one is equal to 50 plus 98, getting us a value which is 148 newtons. That is the value of the reaction when the body is moving upwards with an acceleration of 5 meters per second. Constant velocity, acceleration is 0. Whenever the body is moving with a constant velocity, its acceleration is 0. And now for Roman 2, they gave us the acceleration. So this one minus this one equal to ma. Why? Because the body is moving upwards. If the body was moving downwards, so if this mass was moving downwards, we would be having mg minus r equal to ma. For a body moving downwards, a body which is descending. But this one is ascending, R minus mg equal to ma. Take note of that.